Hello, and what it is. All right, welcome everybody. So here's the scoop, okay? Today, we are going to learn how to take our data that we've written down from our measurements, okay? Let's see if I can. We got our data here, okay? And so you've got your data just on like some page in your notebook, right? So you've written this down by hand. And we're gonna take our data and we're gonna transfer our data into a spreadsheet, a Google Sheet, okay? But we're not gonna use just any old Google Sheet. We're going to use a Google Sheet that's been pre-programmed to do our calculations for us, okay? So all of the calculation methods that that are on the other video, okay, are being completed here for us by this this Google Sheet. Okay, the one calculation type that I haven't demonstrated already on video, which is the density calculation, I will go ahead and demonstrate that on this video. Okay, but first things first, let's figure out how to get our data into that sheet and make sense of the calculations that it performs, okay? So first order of business, right? Here are my data from the marble, the measurements of the marble that I took, okay? So the mass of the marble was 19.13 grams, so the mass in grams from using the balance, okay? And then the volume was 7.5 milliliters from using the beaker. Okay, the volume I measured was 5 mil. Oh, and by the way, so in the other video, I actually said 20. The actual measurement is 7.5. In the video in which I said that the volume from the beaker, the volume of the marble as measured by the beaker is 20, that measurement was incorrect. I incorrectly measured. I think I was looking at the gradations on the beaker and misinterpreting them or something. But I made a mistake when I was doing that measurement. When I remeasured using the beaker, I remeasured correctly and I got 7.5 milliliters, okay? So just in case you were wondering about that discrepancy. The displacement method gave us 5 milliliters. And then we used a ruler and paper, okay, to get the circumference in centimeters of the marble, and that was 7.82 centimeters. And then I got the diameter in centimeters from using a C-clamp. I got 2.5 centimeters, and then I got the diameter from using calipers, 2.44 centimeters. Okay, so these are the data from data collection. All right, and initially I wrote them down on a spreadsheet, but I'm showing you, you know, how to proceed because your data are going to be written on paper. So I've copied these onto paper, and now I'll show you how to transfer them into the prepared spreadsheet that's going to do the calculations for you. Okay, so really cool spreadsheet that we're going to get to use today. All right, so let me go ahead and open this spreadsheet. Okay, and this is called Volume Lab Calculating Spreadsheet, okay? Because the spreadsheet is going to be doing the calculating for us, okay? So the first value that we want to go ahead and put in here is the mass, okay? So we go ahead and okay, we go ahead and add our mass values, okay? So, and I mean, yeah, you go ahead and add your mass value, right? So your mass value goes right here. So 19.13 is what should be placed in every single one of these cells, okay? And so nothing's really going on yet, okay? So no worries, right? And I guess before we even talk about all of that, what I need to just show you is that this spreadsheet looks like this to begin with, okay? So it's got columns for your measurement tool or tools and method. So you measured volume directly from the beaker and from displacement. you measured circumference from the paper using the paper and ruler, and you measured diameter using the C-clamp and calipers. And there are places in this spreadsheet for you to add all of your values. Okay, the first value we're going to add is mass, and so this mass value is actually going to be used for density calculations, and we'll talk about those later. So we're gonna want to put the mass value in each one of these cells here, and the mass value from our balance again was 19.13 grams. So we go ahead and place that into all of these cells. Okay, and I've just programmed the spreadsheet to do that quickly for us. The next thing we want to do is we want to enter our volume that we measured from the beaker. So 7.50, and then you'll notice as soon as that happens, the spreadsheet gives us the percent error and it gives us the density. Now I'll show you how to calculate density in just a little bit, but really quickly for those who can follow, density is just mass divided by volume. So this value over here, 2.55 grams per milliliter, that's 19.13 grams divided by 7.50 milliliters. That's the density we got using this volume measurement and the mass that we had from our balance, okay? And all of these percent errors pertain to the volume, okay? So we're using the known value of the volume and the experimental value of the volume to determine this percent error, okay? As is discussed in the other video. Now, the displacement method gave us a volume of 5 milliliters. So we put that in, okay? And then that gives us a percent error of 34.21 and a density of 3.85, okay, which is also going to be pretty far from the actual value. Next, we're going to put in our value for circumference, okay, that we got using our paper and ruler. And when we do that, right, the sheet just, because it's been programmed, it calculates the volume, it calculates the percent error, okay, and it calculates the density. Then we add our diameter values. So from the C-clamp, all right, now that volume and percent error have been calculated, as has that corresponding density. And finally, we put in the value for the diameter, okay? And we get volume, diameter from the caliper measurement, and we get volume, percent error, and mass, okay? And you'll notice that some of these values are different from the value, like some of the percent error values or some of the other values are slightly different from the values in the other video. And that's because, okay, so the longer calculation video in which we went through all of these volume calculations, and those differences are due to rounding error, okay? So the spreadsheet is rounding differently, a little bit differently than I rounded on my calculator or than my calculator internally rounded, okay? So don't worry about those minor differences and discrepancies, all right? So what you're going to do is the exact same thing that we've done here. You're going to enter your data values throughout this spreadsheet, okay? So let's go ahead and do that again from the start, right? So first order of business, we add our mass value to every single column, every single row of that column. Okay, so we put in 19.13. Well, in my case, that's what I put in. You're going to put in your mass value for your golf ball. So remember, I'm measuring a marble, you're measuring a golf ball, okay? Same process, you're going to get different results. So you put in your mass value in every single one of those rows for that column. Then you add your volume from the beaker, okay? So you add the volume that you got from using the beaker to measure the volume of your golf ball. Then you add the volume that you calculated or measured by using displacement to determine the volume of your golf ball. Then you add the value for circumference of your golf ball that you got by using paper and ruler. Then you add the diameter, okay, that you got from using the C-clamp, and then the diameter that you got from the calipers, okay? And then your data table will be complete, all right? And a couple little last things. These cells here that say NA, N divided by A or N over A, and sometimes uppercase, sometimes lowercase, stands for not applicable, okay? So because we didn't calculate the circumference or the diameter of the marble using beaker or displacement, right? That's not what those measurements are for. I typed NA in there in the sheet so that you would know that your measurements would not go in those cells, okay? So the only time we calculated circumference was when we were using paper and ruler. And so you put your measurement right there in that particular cell, okay? Same thing for diameter. Diameter, as measured by the C-clamp, you put that value right there. Diameter is measured by calipers, you put that value right there, okay? And the table just takes care of the calculations for you. As I said in the other video, because I don't expect you to do those calculations, okay? I want you to be familiar with them. I want you to have them in your notes, but I don't expect you at this point in your mathematical career to be using those calculations in an applied fashion for science, okay? But if you see them in math class, you'll know how to, you'll be familiar with them, okay? So, all right, so last bit of business, right? So how do we calculate density? Okay, so let's go through this density calculation that we discussed earlier. So if we want to calculate density, okay, density, and really what we're calculating in this case is the density of glass because this marble is made out of glass. What we're gonna do is we're going to divide mass by volume to get density. Okay, so let's just go ahead and put that calculation right on this page, right? So density, and you can put this in your notes. That's a very good idea. Equals mass divided by volume. And in this case, you would have 19.13 grams, okay, right here, divided by 7.50 milliliters, right there, which equals 2.55 grams per milliliter, okay? That's our density, okay? 2.55 grams per milliliter. And that's actually really, really close. We did a good job with this with these measurements, okay? The actual density of glass is 2.50 grams, okay? Grams per milliliter. So we did really well, okay? These measurements were very good, okay? So mass measurement, very good, and beaker volume measurement, very good. All right, so that's how you calculate density. That's something you'll absolutely want to know for our class. Okay, so that's all. Now you should be able to take your data, right, from paper, plug them into this spreadsheet, and get all of your calculated values for the lab, okay? So this gives us, this process will give you your results table for your volume lab, okay? Your golf ball volume lab. All right, guys, so that's it for now. You got this, okay? But as always, may all of the forces be with you.